In this video, we're going to do the sum from k equals 2 to infinity of k minus 1 all over k times 2 to the k. Also, don't forget to subscribe and turn on notifications so you don't miss a video. Okay, we can write this as the sum from k equals 2 to infinity of k over k times 2 to the k minus 1 over k times 2 to the k, just separating the fractions. And k over k will cancel, leaving us with the sum from k equals 2 to infinity of 1 over 2 to the k, right? Because 1 to the k is still 1, so we can write it as 1 to the k over 2 to the k, which is 1 over 2 all raised to the k. And we can actually split this into another sum from k equals 2 to infinity. We can write this as 1 over k. Same thing, 1 to the k over 2 to the k, which is 1/2 all raised to the k. Okay, so now we're going to look at the sum from k equals 0 to infinity of x to the k. So this is an important series, but it will be the first term all over 1 minus x. The first term is x to the 0, which is 1. Okay, so now let's integrate. Before we integrate both sides, let's look at the domain. So x has to be between -1 and 1, and that is the property of this power series. Okay, let's integrate both sides with respect to x. On the left-hand side, we're going to have this, the sum will stay the same, k equals 0 to infinity. This will be the reverse power rule, so this will be the integral of x to the k, which is x to the k plus 1 over k plus 1. We're going to put the plus c on the other side because it looks better. The integral of 1 over something, that's x to the first power, will be ln absolute value of 1 minus it, so the same thing, divided by the derivative. The derivative is -1, so we're going to divide by -1. And then we have plus c. The domain of the first power series stays the same, but now we can check the endpoints. So let's just check the endpoints for a second. So at x equals 1, we'll have the sum of 1 over k plus 1. This is the harmonic series. This diverges. Okay, so we have x equals -1. That's the other bound, or the other endpoint. So that would be -1 to the k plus 1 over k plus 1. And this actually converges. So at -1 endpoint, you can say x is greater than or equal to -1. Okay, good. So now we can plug in x equals 0, because we want to find out what c is, because we don't like c. So on the left-hand side, you have the sum from k equals 0 to infinity of 0 to the k plus 1 over k plus 1 equal to minus ln absolute value of 1 minus 0, which is 1, plus c. ln of 1 is 0. Now this, it's not 0 to the 0 because k is equal to 0 to start with, so that would be 0 to the first over 1, etc. So this is all 0. This means that c equals 0. So we have the sum from k equals 0 to infinity of x to the k plus 1 over k plus 1 equals negative ln absolute value of 1 minus x. And now x is between 1 and -1, but it can equal -1. Now let's check this absolute value, because let's see if we can get rid of it. Okay, so the lowest value, it won't ever approach 0. 1 minus x will never approach 0 because x is never 1. And the highest value this can get to is 1 minus -1, which is 2. So this means we can just use parentheses instead of absolute value. Okay. So now what's next? So our sum, both our series start at k equals 2. So let's plug in 0 and 1. Okay, before we do that, we notice this starts at 0, but this is x to the k plus 1, not x to the k over k. So let's get rid of this plus 1, but now we have to move our sum up by 1, so we still get x to the 1 over 1. Okay, good. So now let's plug in k equals 1 to start with, so that would be x to the 1 over 1, which is x, plus the sum from k equals 2 to infinity of x to the k over k equals negative ln of 1 minus x. Okay, so to get the sum from k equals 2 to infinity of 1 over k times x to the k, this will just be minus x minus ln of 1 minus x. We still know that x has to be between -1 and 1, and it can be equal to -1. But we won't be plugging in -1. Okay. So we have 1 over k times 1/2 to the k. So this means that x is actually, let's plug in 1/2. So this would be the sum from k equals 2 to infinity of 1 over k to the times 1/2, all raised to the k. So now we're going to plug in 1/2 on the right-hand side. This will be negative 1/2 minus ln of 1 minus 1/2, which is 1/2. This can be written as negative 1/2. 1 over 2 is 2 to the minus 1, and then ln of 1/2. We take the negative 1 and put it in the front, so this will just be negative times negative, which is positive ln of 2. So that's what this sum is. But that's not what we're after. Okay, so how to do this first one? So this is the first term. What's the first term? So that's 1/2 raised to the 2. So that's 1/4 over 1 minus the ratio, which is 1/2, minus, so now we're going to plug in negative to this, which would be negative times negative, which is positive 1/2, and then we have minus ln of 2. Okay, good. This will be 1/4 over 1 minus 1/2 is 1/2. Now we're going to multiply 2 on both top and bottom to cancel stuff out. So let's keep it the same. Okay, 2 over 4 is 1/2. 1/2 plus 1/2 is 1. So our final answer is 1 minus ln of 2. And that is the end of the video. Hope you liked it.